All right, folks, I got to get to the right lesson here. We're going to be doing lesson 5 today, and this is exponential regression, okay? Now what regression is basically if you're given a whole bunch of dots of data, okay, this is all input. What regression does is it tries to form a line of best fit. It tries to show you what's happening. So it's not perfect, but it does try and connect all the dots together. So we're going to be using our graphing calculator, so you do need to have one handy and try and follow along. So you can pause the video, try and figure out which buttons I'm selecting. Now I will warn you that the app I'm using here for the graphing calculator is not exactly like the TI-83s that you might have. So stuff is going to be similar, but it might not be exactly what you have. So I encourage you to, pause the video, click buttons. They're going to be in the same sort of area on your calculator. They just might not be exact. All right, so the first question is, well, how do we input this information? Because we're going to eventually want to graph this stuff. Okay, so what we're trying to do here is create, a graph that shows, the time on the bottom and then the number on the side. So we need to find a way to input this stuff into the calculator. And there's one spot where you can do that. And it's kind of right in the middle. It's just above the stat button. So I've highlighted the stat button here, okay? And you'll see that it says edit, okay? Again, that stat button's right around there. It's going to be in a similar spot on your TI-83. So if you hit that stat button, this menu is going to come up, and you want to hit edit, and then hit enter, okay? Now, yours may be blank. It might have some information in here if you've had a sibling or somebody that's gone in the past. So it might look like this to begin with. There is one other important thing we need to do, which maybe I'll explain in a bit. But for now, let's try and put this information in here. So the one thing we want to do is you can do this 2 different ways, okay? And I'll try and show you the difference here. The year is our X values, and the population is our Y values, all right? So we're going to put in, you could do 2002, and then 2004, and then 2005, and then 2007, and then 2009, okay? And hit enter each time. So again, you can just go to the spot you want, type in the number, and then hit enter, and it'll store it in that value, okay? Now L2, we're going to do the corresponding Y values. So 5564, 6121, 6300, and 6812, and 7422. Okay, so we've got all those values. Just double check that they're all correct. And then we can actually calculate an exponential regression equation. So we're going to be doing this equation here, which you should have seen before. A represents the initial amount. B represents like the factor by which we're multiplying. So the multiplying factor. If you recall, it might be like if it's greater than 100, it's going to be exponential growth. If it's greater than 1, it's exponential growth. If it's less than 1, it's exponential decay. So just make a note that if B is greater than 1, that's growth. Okay, and if B is less than 1, that's going to be decay. So just predicting here, it looks like the population is growing. So we should have a value greater than 1. Okay, so here's the question. How do we actually get the equation? So step 1 is to put the information in. Step 2 is we're going to calculate an exponential regression. So that same button where it says stat, you're going to hit that. And then at the top it says calc. So you got to scroll over. So you just hit the over arrow to get to calc. And then you're going to start to scroll down. And you're going to see this EXP REG, exponential regression. Hit enter. Now this is the weird thing about my app is I have to do it twice to actually make it do it. Yours, hopefully it does it the first time. EXP. All right, so our X list, you hit L1. Our Y list is L2. That should kind of just be default. If you wanted to pick different lists, you can actually change this to L3, L4, whichever list you've got it stored under. Don't worry about the frequency list. Under the store regression equation, we want to store it in Y1 in your graphing calculator. So to do that, you hit the vars button. And again, your menu might look a little different, but you need to go to Y vars, Y variables. Under function, hit enter, and then you'll see Y1. Okay, and we're going to store it as Y1. And then hit enter. And we get this information here, that our A value is this teeny tiny little number. And students will get messed up with this number where it says e to the negative 32. Now that means it's a very, very small number. And our B value is 1.04. Now the problem with our A value being 4.75 times something, something, something to the negative number is it's wanting to take a graph from the year 0. Okay, so our first X value here would be 2002, but it's starting our graph at 0. So if you kind of picture this at the year 2002, which might be way over here, you're going to be at 5,000. But what about the year 0? Well, because we're doing growth, it's going to go all the way down to this tiny little number. And it's fine. You just need to know that your A value has those e times 10 to the negative 32. So our A value is 4.76 times 10 to the negative 32, and our B value is going to be 1.041. Now the other way you can think about this is let's call the year 2002, because that's what we're really concerned about. That's going to be like 0, our starting point. 2004 is going to be 2, right? Because it's 2 more, yeah. So this would be, well, let's call the year 2000 0. 2002 is going to be 2. Oops. 2004 would be 4. 2005 would be 5. 2007 is going to be 7. And 2009 is going to be 9. All right, so we're going to change our L1 list to 2, 4, 5, 7, and 9. So 2002, 2004, 2005, 2007, 2009. A little easier to think about that, okay? And we're going to calculate the exponential regression again, L1, L2. I don't know why it doesn't like me doing it the first time. There we go. L1, L2, and then again storing it as Y1. We get a bit of a different equation. We get an A value of 5,157.92 and a B value of 1.041. Now it doesn't really matter for the purposes of calculating stuff. You just have to think about how you've changed your scale. All right. So graph the exponential function for the years 2000 to 2050 using your graphing calculator. So that means our window is going to go from our x minimum is going to be 0, representing the year 2000, and our x max is going to be 50, representing the year 2050. And our y max, we should probably be more than our maximum number here. So let's go to like 15,000 or so. Okay, double that, I'm going to guess. Let's see what that looks like. We've got some other stuff going on, so let's delete y2. All right, so there's our exponential function, and we can double check here. So if we go to second calculate value, and we're going to go to the year 2002, so 2, you'll see that's pretty close to what we have. If we go to second calc value for 4, representing 2004, again, that 6,061 is pretty close to what we have there. Let's go to 5, just double checking how this sort of fits with our information. Yeah, pretty close. Second calc value in x is 7. Again, we're pretty close to what we're doing there, okay? What percent does the exponential model increase by? Well, our B value is 1.04, so that's a 4.1% increase per year. What is the population in the year 2006? So second trace gets us to these menus, and we want to do value when x is equal to 6, representing 2006. And we get a y value of 6,570.21, okay, or 6,570, what are we talking about here? Population, so people. Use your graphing calculator to determine the number of years to the nearest year when the population will reach 20,000. Well, the population are y values, so on your calculator, set y2 equal to 20,000. And hit graph. Now nothing shows up, but there's a slight problem with our window settings here. My y max currently is 15,000, meaning it can go up to a maximum y value of 15,000, but we want to see 20,000, so we need to increase our window settings to include at least 20,000. So let's go to like 25,000. Okay. Hey, that second line shows up, and this line here is right at 20,000. Okay. So if we go to where it intersects, whoop, there it is, right around 33. And we can calculate that intersection exactly. So again, second, and hit the trace button and go down to, second calc intersect. And on my calculator, it asks for the left boundary and then the right boundary. And there it is. So when x is 33.59, so what year is that? Well, that's in the year 2033. Okay? So in the year 2033. It's almost, it would be closer to the year 2034, but it's in the year 2033. So we have exponential equations. This one is exponential growth. If you had one here like this, it would be exponential decay. This one's linear. So that's our answer. This one is also pretty linear, and this one is logarithmic. Okay, so one of these two are going to be exponential growth or exponential decay. Let's do another example of where we need to change our list. So we have years since introduction, so that's going to be our time, L1, and L2 is going to be our population. So again, hit Stat, Edit. Now we're going to edit our Y list, so 2, and then 5, 7, 11, and 15. Oops, I messed something up here. Let's try that again. 2, 5, 7, 11, 15, and then input your other information here. So 75, 100, 112, 205, and 290. There we go. We want to calculate the exponential regression equation, so go to Stat, and here's where I have to do this twice all the time. Go to Calc, and then EXPREG, hit Enter, and then I got to do it again. Yours should show up the first time. All right, L1 is our X list, L2 is our Y list, and then we want to store this as Y1, so hit vars, go to yvars, hit function, and Y1, and we get this exponential regression equation. So we're going to go y equals 58, and what are we doing? Round 8 to the nearest 10th, so 58.9, and b we're going to the hundredth, so 1.11 to the x, okay? And that's our exponential regression equation. So if you go to y equals, you should see that stored, that same stuff stored in y1, okay? Now y2 we don't need anymore, so we can clear that. Use your graph equation for between x is between 0 and 20. So that means go to your window and then go between 0 and 20. And let's think about what our y max should be. Well, at 15 it's only at 290. So a y max of 25,000 seems quite aggressive. So let's clear that and maybe go to like 400, 500 maybe, at most. And hit graph and see, hey, that looks pretty good. Based on your model, what percent is the rabbit population growing each year? Well, 1.11 means 111%. So we have an 11% increase. Okay. What is the population of rabbits 3.5 years after being introduced? Well, that's an x value of 3.5. So on your graphing calculator, you're going to second trace button to get to the calculator menu. And we want to do value when x is 3.5 and hit enter. And we get a population of 84.89. So calc value when x is 3.5, and you get y is equal to 84.9, so 85 rabbits. Graphically determine the 10th of a year when the rabbit population will reach 350. Well, that's a time value, so let's set y2 equal to 350. So go to y2 and hit 350, and then hit your graph, and you'll see that we have an intersection right around 16, 17 years. We can calculate that exactly. So second, hit the trace button to get the calc menu and go to intersect. On mine it says left boundary and then right boundary. On yours it'll just say first line, second line, I think. Hit enter, enter, and then enter a third time. And you'll get an intersection when x is, I should put the instructions in there, calc intersect, and that gives us a y value of, an x value of 16.63. So that's 16.6 years. Another example here. So we have to go and edit our lists again. So hit stat and then edit and then put in your new information. So our L1 is our time and our L2 is the infiltration rate. So 0 and then 1.5, 3, 4.5, and 6, and then 5.3, 3.1, 2.4, 1.6, and 0.7. So our y values are decreasing, so this is probably going to be decay. So I'm predicting our b value is going to be less than 1. So go to stat, calc, scroll down to exp, reg, and this is where I have to do it twice, but you should only have to do that once. Okay, L1, L2, and we want to store this as y1, so go to vars, go over to function, hit y1, and then hit enter, and we get this equation. So we get y equals, and we want to round each variable to the nearest hundredth, so 5.47 multiplied by 0.73 to the x. Okay. Now this r squared value I haven't talked about yet. My app doesn't show it on this calculator. Let's finish this question off and then I'll come back to the r squared question if I can remember what I'm talking about here. So graph the equation using your calculator for 0 to 15 on your x values. So go to your x max. We're going to go to 15. Why 15? Well, our x values are kind of going up here, and what we're doing is we're going to when x hits 15. So our y max, since things are decreasing, our y max is actually at the beginning of our stuff. So like we only need to go a little bit more than 5. So let's go to a y max of 6, and we actually don't need to go that negative on our y. So there's our information. Okay, you can see that 0 is the x-axis, and we've graphed it. That's part B. Based on the model, what percentage is it decreasing? Well, our b value is 73, or 0.73. So if we go 100 minus 73%, it's a 27% decrease. Okay, we're keeping the 73%, but we're losing 27%. Determine the infiltration rate after 4 hours. So that's an x equals 4. So on your calculators, go to second, calc, value, when x is 4, and hit enter. And you get a y value of 1.56 inches per hour. And the last one, determine the time till it reaches 0.25. So that means we're going to go y2 is 0.25 because it's a y value. So delete this and we get 0.25, hit graph again, and you should see the two lines. And if you scroll close, you can actually calculate the intersect. So go to second calc intersect, okay, and go to enter. If you've made it that far, that's my fantasy baseball team. Not mine, but another person in the league. All right, and we get an x value. We get an x value of 9.82. So after 9.8 hours, it's going to reach that absorption rate. And I think that's the end of that lesson.